Two-point linear fitting has to deal with transforming values so they have the same relative position in the output range that they had in the input range. There's three routines that I'm going to look into. Normalization, where you have a custom input range fit into the unit range. Linear interpolation, where you have the unit range fit into a custom range. And rescale, where you have a custom range fit into another custom range. To do this rescale operation, my go-to node is the remap node by LWNodalSetups tools, because it's a very concise node and simple for this particular operation. So here I put the values that I want to transform. Here I set up my input range, and here I set up my output range. Well, let's look at that in layout. I have here that setup with instances where I graph things. So I have the base position of the instances on the X linked to the offset on the Y, so I can check the input against the output. So in this case, nothing is being actually transformed. I have my output equal to my input, but I'm using this remap node and it's being driven by two objects, object A and object B. So I'm using these objects X and Y position to set up my input and output range. So AX and BX define the input range, AY and BY define my output range. So when I move them on the X value, I change the input range, and when I move them on the Y value, I change the output range. And with this, I can have a visualization of this linear conversion. Usually we won't see these things, so this is just for demo purposes, although that sometimes maybe if you want to check what's going on with some calculation, you can plug it in here to just see if your assumptions are correct. But usually we don't have a way to easily inspect things like this. So this remap node also offers me this option to clamp the values, and what this will do is that it will kill off any extrapolation. So values that are between A and B are interpolated. Values that are beyond A or beyond B output value will be cut into those output values. So no output value goes above B's output value. So from that point on, I get this constant value, and no output values will go below the output of A. So I get this constant value beyond A. So this is a nice option. If I can use a native node to sort of do this. I come here and I use, say, the gradient. I click show output, create another key, show output, and I have now some ports that work in a similar fashion that these ones, just a different setup. So to set up my input range, I actually use the keys position. So AX goes onto the first key position, BX goes onto the second key position, AY goes on the first key alpha. So the output range can be defined either by the alpha or the color. That's why here in this schematic, you can see that I have AY and BY signaled 2 times. So in this case, I'm dealing with scalars. So I'm going to have AY go into the first keys alpha and BY going to the second keys alpha. So when I choose what value that I want to transform and I plug it in here and I plug the alpha here, you'll see that I get the same result. Now, 2 things to consider with the gradient. First is that there's no extrapolation. It's always clamped. So I can never have, this configuration. I will always have this one. Secondly is that when the input values cross, when the first key position goes above the second, this basically doesn't work anymore, as the transition, you don't see the transition update. So in this case with the remap, we still see the transition going from A to B, regardless of which position is the greatest. So these are 2 things that make me use the remap node instead of the gradient whenever I want to do this scalar rescale operation. Now, I said I was going to break this node into 2 distinct operations, and that's why I have this compound here called remap example. You'll notice that the only difference is that the output range allows for vector values, but here in this context it won't make any difference. So if I plug this in here, I'll get the same result as with the remap. So if I open this up, you'll see that I have 2 operations. I have box step and I have a mixer. So box step is performing normalization. It's creating a gradient, creating relative positions from using the input range. Linear interpolation, here being done by the mixer, is using those relative positions, those scaling factors, to distribute to output values. So it will use this 0 to 1 range to decide if it either outputs A or B or a blend of both. So I'm going to look into these two routines separately, and I'm going to disconnect this here. I'm going to reset this object here and put this one in here. Okay, so let's talk about normalization. Normalization on vectors is when you have a vector and it has any length other than 0, and so you make it become with length 1. It doesn't matter how long the vector is, when you normalize it, the length becomes 1. So here we have sort of the same thing. I have this vector here, AB, and it's transformed into becoming just 0 to 1 vector, so length 1. The evaluation of the transformation that is done to the values, say I have this value here, and the way I evaluate the transformation is that I have that AB vector, and then I have this AX vector that goes from A to the value that I want to solve. So A becomes my new origin, so I have both vectors at the origin, and then I just compare their length. What do I need to do to B so it becomes like X? So basically, in this case, I have my starting point, AB, and where I want to go, AX. So this is a scaling factor, and it's described here with this equation in which I compare the length of the two vectors. So the scaling factor is basically the relative position of the input value in relationship to the two reference positions. And so I can check that in here with, say, this gradient meter object, in which I have a displacement, a nodal displacement setup, where I have here this morph. So this input is in with percentage, but I can feed a scalar value to it. That will work the same. So scalar, so if I have this scalar at 1, the morph amount will be 1. But if I have this scalar value, say at 0.5, you know, this morph is basically controlling the height of this purple strip. So now it's in between 0 and 1. And as I put it down, you see that it comes down to 0, to this 0 marker. So this morph is just controlling how the position of that tip of the strip is between 0 and 1. Now, let's say that I want the position of the object on the x-axis, depending on if it's closer to A or closer to B, to define the morph amount. So I can use box step for that purpose. Scalar box step, and I can put this in here. So this is the value that I want to transform, the object itself x position, and I want to transform it with two reference points, object A x position and object B x position. So this is my input range. So when I put this here, you can see now that as I move the object between A and B, the morph will go from 0 when I'm close to A to 1 when I'm close to B, and all those relative values in between. So one example of normalization is when we do a UV map. When I come here, let me put this in the UV view, and let me do a new UV map. So planar projection, I'm going to choose the z-axis, and you'll notice that I have some values here put in there for me already. I haven't put them there myself. If I run the bounding box command, you see that I have the same values that I have in here in the center and extent, center and size. I also have two other values called minimum corner and maximum corner. This minimum and maximum corner has the same relationship with the, when I have here the remap node, the minimum and maximum of a range. So in this case, this will be the same. So this minimum corner will be mapped onto 0, and the maximum corner will be mapped onto 1. It's just that they're being, in this case, they're being used for UV. So when I click create, what I'm doing is I'm mapping the x position of my mesh between 0 and 1 on the u coordinate, and I'm mapping my mesh points, the y coordinate between 0 and 1 on the v axis here in the UV editor. So I fit this object that is a bit rectangular into this square. This is very useful, for example, for rendering. So let me hide this object here, bring up the fish, and come here to the surface editor. And so I can call the UV map I've just created. And if I turn on VPR, if I link this here, you see that I get this gradient from this UV that I created in Modeler right now. So in this case, I get a gradient on the x-axis, but if I plug in the v, I get this gradient from 0 to 1 on the y-axis. So vertex maps are a very neat way to build up data that you can use then in the node editor. Thing is that it's static data. Of course you can manipulate it, but by default is static. You cannot change that bounding box that you used in Modeler to create the UV. So let's let's make our own bounding box here in layout to create this gradient. So I'm going to create a gradient on the x-axis like this one. And so for that, I'm going to use box step again. And the value that I want to transform is the world spot x position. And I want to use as my input range these two objects, A and B x position. So when I put this in here, you see that now I have a gradient that goes between A and B. So I effectively created a bounding box for the normalization here in layout directly. Now, one thing to notice about box step is that it's always clamped. There's no extrapolation with it. It's hard for us to see that here in the computer monitor because the values we see only go between 0 and 1. Negative values and values that go over 1, they look the same to us as 0 and 1. So one way to check it out here is I created this gradient that starts at -1 and goes up to 2. At 0, it still has 0 value. At 1, it still has this white value or 1, but above that it has green, and below 0 it has red. So if there's any extrapolation, I'll be able to see. So if I plug the box step in here and I plug the color in here, you see that I still get the black to white gradient. So there's no extrapolation with the box step. For this reason, this is why whenever I want to do a normalization, I don't use box step, but I use the remap node again. Reason for that is that I can still, even though that I've said that I use remap mostly to do rescale, if I leave the output range untouched with the default values 0 and 1, basically what I'm doing is I'm rescaling to the unit range. So I'm doing normalization. On the other hand, if I leave the input range with the default values 0 and 1, well, in this case, I'll be doing linear interpolation. So I can use this node to perform either any of these three operations. So in this case, I'm going to use it to do normalization. And so I'm going to do the same thing. This is the value that I want to transform, and this is my input range. So when I plug this in here, you now can see colors in there. So there's extrapolation. There's values that go beyond 1 and values that go beyond 0. I can also, of course, have this look like the box step by clicking the clamp values. So in this case, there's no extrapolation and it will work just like the box step. But, it's nice to have the option. That's why I keep using this one whenever I want to do some normalization effect. Okay, so we've seen how I can create a gradient. And now let's look into the operation that uses this gradient to distribute values. That's linear interpolation. So let's look into that. I'm going to turn off VPR and I'm going to this item motion node editor by Denis Pontonnier. So here I'm going to I have object B and I'm going to link object B position X into the fish position X. So now when I move the B on the X-axis, the fish will follow. So maybe I want to change how much of an influence this object B has on the position of the fish. Maybe I don't want I don't want it to match. Maybe I just want half of the influence. So a way to do that is to use the mixer and put in here, link there, and say if I want half, I can put, say, 50%. So now you see that it doesn't follow B. It doesn't match B completely, it just follows it, goes half of the position of B. So this is a way to dose the influence of something. So I can put it at 25. If I put it at 0, it doesn't follow B at all. If I put it at 1 or 100%, since this is a percentage input, you can see that now it follows B strictly. If I try to do the same thing on scaling, let's say that I want to have the X scaling of B driving the X scale of the fish. So when I scale B now, you'll notice that the fish always scales on the x-axis. Let's say I want to also control the influence of B on the fish scaling. Well, I put this here. I do the same thing. I put this here. So at the moment is strictly following B, but if I put, say, 50 or 0, well, you notice that the object got scaled to 0. So what happened? Well, the problem here is that position is additive. So the default value is 0. So here in the background, I have this black color. This black color will translate into a scalar that is 0. if I notice, I have the same black color here used in scaling, but the scaling is a multiplicative parameter, so I need 1 as my default value, as 1 is the base of multiplication. So now this will work out correctly. So here's the full influence of b, and as I move the opacity down, the influence of the scaling of b goes to 0, and I have my default scaling value 1. Okay, so this is an example of how to dose the influence of things that you are driving. In this case, I can just use these two objects to blend between both. So I can say, instead of just having bx here, I can also have ax. And instead of having just the scaling of b, I can have the scaling of a as well. So now with this, let me bring here a scalar constant. If I have this scalar at 1, I'll have the object follow b strictly. If I have this scalar at 0, it will follow a strictly. But if I have any value in between, say like 0.5, it will blend between the two objects driving the fish. So I can basically, in this case, create a 2-point constraint in which, regardless where I move a or b, the fish will be constrained in between. And if I scale this object like this, and this object like this, the fish scale will be constrained between the two objects scaling. So as I increase this, as I increase the scalar, it goes to b. As I decrease it, it goes to a. So this is an example of having a scaling factor controlling the influence of two reference values. So now let's bring these together. One thing that I'm not sure if I mentioned, we are in item motion node editor, and this was the first node editor that allowed me to manipulate motion channels. We now have one called nodal motion. The issue with nodal motion is that it only has vector outputs. So if I want to constrain just a single channel, I cannot. I have to constrain all the position channels, for example. So say I wanted to have this fish object constrained on 2 in the y-axis. I can constrain it there. So if I try to move on the y-axis, it doesn't do anything. But I can still interact with it on the z-axis and on the x-axis. So it's a nice way to do partial constraint instead of using the vector output and constrain all the channels. So another issue that I would like to point out is that the mixer is a bit annoying if I want to deal with, values that are not color. So it has this color UI, and if I want to say, instead of having 0 and 1, so 0 and 1 I can do easily, right? I can have black and white, and this means 0 and 1, as I can see here in the input SPI. So this is okay, it's easy to do. But if I want to do, say, 2 or -1, it's much, it's tricky. So if I want to do 2, if I have the correct options in here, I can just come here to X and put 2, and now I have 2 coming out. But I can't use that same thing to do, say, -2, right? It puts 0 in there, and I just get black. So this will force me to use scalar constants. So if I want -2, I put that on the constant, and I put it in here, and now I can have -2 being output. So that's a bit annoying. And the other thing is that if you want to have a clamp going on, you have to do it yourself. So unlike the remap node, for example, where you have a clamp, so let's say, for example, here with the position and the scaling. So if I put, say I have these, sorry, I plugged this in on the wrong port. So if I have A and B here manipulating these object positions, say if I go overboard, if I say put 2, you see that now the fish will be to the right of B, the same exact amount that A is to the left of B. So I have some extrapolation going on in here. So the mixer doesn't allow me to clamp right here. I don't have a button. So I have to manually put a clamp node in between. So I can put this here, and okay, now it's clamped and it doesn't go beyond B, even though the scalar value is 2. Same for values that go above 0. So if I put -1, you notice that now the fish is to the left of A, the same amount that B is to the right of A. And of course, I might want to cut off that extrapolation by clamping it. And now, even if the value is negative, I get back A. So this is something that you have to do it yourself with the mixer. There's no option. Okay, so let's bring these two together. I said I would break this operation, this rescale, into normalization and linear interpolation. So now let's use them together to basically do a rescale, and something that we can do, say, in modeler when we do, for example, a twist. So when I come here with the rotation tool and I do a fall off linear, you see that when I rotate this object, this portion here rotates fully, this portion here rotates nothing, and I have an interpolation in between of the effect. So this I have this gradient. If I click N, you see that there's this widget that shows that linear fall off that goes linearly from 1 to 0. So we can do that in layout. We will notice that, you can notice that, oh, I let the object update. Let me undo that. So I can do that type of effect here. If you notice, if I come here to displacement and I can do, say, twist, it asks me for 2 points, 2 reference points. So this is basically what we have been dealing with. And same thing for shear and taper, always asking for 2 reference points. So twist is basically a rotation with fall off, shear is a translation with fall off, and taper is a scaling with linear fall off. So let's do the 3 of them by building up the fall off, the gradient, and then applying that fall off to in a linear interpolation to blend between the two types of transformations. So let's come here to the fish displacement node editor, where I have object A and object B, and I have this spot info node that will give me my fish X position of the points. So first off, let's right off the bat, let me use remap node to do a gradient. So I'm going to normalize those values between A and B, just like I've done here in texturing. So if you remember this this gradient that I've done here, I want to do the same gradient, but in this case, usually you don't get to see the gradient. Here I just did it so you could see it. But so I'm going to do that same gradient by normalizing my fish point positions between A and B. So now I have a gradient going on, and then I'm going to use linear interpolation with the mixer to basically distribute 2 values using that gradient. So okay, the values that I want to distribute, in this case, I'm going to perform shear. So shear is when here we do, for example, we put a linear fall off in the move tool, and we one part is moved, the other is not, and in between values interpolate between those two, between 0 and 1. So we got this fall off going on. Okay, so I'm going to do that here in layout by using these 2 objects Y position. So AY goes into the background, BY goes into the foreground, and now when I plug this here on the Y axis, as I move this this one up, you see that this part comes up. Let me see if I'm doing, oh yeah, I have a keyframe in here. Let me see, yeah, I also have a keyframe in object A. Let me delete that. Okay, so as I move this object B up and down, you can see that this part follows it and this part doesn't, but there's some extrapolation going on. As you can see, this part that goes beyond A goes, keeps going. So I can cut that off if I want by clicking clamp values. So now there's no extrapolation and I don't have, this keep going up. So this is just one transformation. Let me do the taper and the twist. For that, I already set up here in this compound called black box. I just called it black box so you don't worry too much about what's going on in there. But basically I have the same object A and object B, position, rotation, and scaling being influenced by any scalar gradient that I put in here. So I have these 3 mixers blending those properties and then feeding them into this transform 3D object. This is this transform 3D vector. We're going to look into it later on. So if I plug the same gradient that I've done here in here, and I put here on the delta, well, still have the same, but as I rotate A, for example, you'll see that now I have the twist effect, or as I, for example, scale A, I get the taper effect. And as same thing, if I go instead of manipulating A, if I manipulate B, I can twist and I can taper. So, and I can still, change the range after. So I can even cross over, and now I have the transition happen in another way. So this brings these 2 together. Another heads up about the mixer is that when you come here and you search for mixer, you notice that there's two mixers. So there's something to be careful about this, because I'm gonna hide the fish now. I've made my point about using normalization and linear interpolation to perform a rescale. And so I'm just gonna give a heads up about the mixer. Going to instances here, for example. So I'm gonna use this remap example, and okay, see if this is working. Yeah, it's working. Okay, so here I have this mixer, but when I come here and I search for a mixer, you'll notice there's two entries. This second one is the native one, and you'll notice that it has this sphere as a preview. The first one is one by that belongs to DP filter, and you'll notice that the preview is a square. Well, these nodes are very similar. You cannot see any difference in the UI. The only thing that you'll see different is the preview. What happens is, if I try to use this node the same way as this one, you'll notice that nothing will happen. So it simply doesn't work in this context of instances. So this is very worrying. And to be honest, there was one or two times that I had a node tree that I knew it should be working, but it wasn't working. So I had to start to debug my node tree to check if the components I was using were doing what I expect them to do. So when you break the confidence on some component that you're using, it's a bit annoying, because suddenly you thought, okay, I can trust in these components, and when one of them doesn't work, it's annoying to have to check out and understand which one is not doing what you want. So in this case, it was because I had a mixer that I thought it would do the same as this one. I didn't even know this wasn't the native one. I wasn't aware that there were two of them. So be careful about that. One way to avoid this is to basically delete this other mixer by coming here to edit plugins, group them by file, come to DP filter, come down here to this mixer and just delete it. I cannot do it now because I have that lock in there because I'm using it. But if you just open layout and you come here and you delete it, you can do that, and then this mixer will not show up anymore here in the list. So just a heads up, because I've I've lost some hair over it. Okay, so last thing I want to talk about here is about gradient node again, and I want to talk about it because it allows something that I mentioned in the introduction. So here I have these eyelids being controlled by this object. As I move the object up to 1, the eyelids open. As I move the object down to -1, the eyelids closed. So here we could say that instead of having a range that goes from -1 to 1, I actually have two ranges. One range goes from -1 to 0, and the other range goes from 0 to 1. So it's not just one linear transition, but two. Now I can do these by separating and creating logic nodes that will basically, do some branching. So I can either go to this range or I can either go to that range, and that is fine. But the gradient node is a nice way to do this, by default. So let me bring up here an object to show that. Have this silly face object and the control for it. Let me go into the displacement node editor, see what's going on here. So I already set up a couple of things in here, but let's look at what I want to do. Let's say that I have two procedural textures that I want to displace the mesh with. So I just use the object point position and I plug here this color into this scale and I plug it in here. I see that this goes on, right? If I plug this other texture in there, you see that I have a different effect. Maybe I want this effect to be a bit toned down. So I'm just going to multiply, scalar multiply, and whatever goes in here is multiplied by 0.5, so it's not so abrupt. Okay, so say that I want to have this control object at this position have no displacement at all, but as I move it to 1, I do a linear interpolation to one of these textures, and as I go from 0 to -1, it does linear interpolation with the other texture. So for that I can use the gradient node. And instead of having 2 keys only, I set up 3 keys. So let me put this in -1. I'm going to create a key in here, click show output, and I'm going to create another key in here and click show output. So the key in the middle, I want it to have no influence, to be neutral. So in this case, I want the alpha to be 0. And the other two keys, I want them to be driven by the what comes out of these procedural textures. So I'm going to put the color into this first key alpha, and I'm going to connect this texture into the second key alpha. So to drive the input, I'm actually going to use this this null X position. So if I connect this here and I connect the alpha in here, what happens is when the null is at 0, I'll have nothing happening. But as I move the null up to 1, you see that this texture comes into play. Now, if I'm at 0 and I move the null into the -1, you'll see that this other texture comes into play. So this is a way to being able to have multiple things evaluated linearly. Of course, I could keep going on, I could add more keys, a key at 2, 3, 4, 5, etc. But in this case, I think this one is a more common case in which you want something in the middle to be neutral, and then you want it to move it to the right and to the left and have two effects. So another way to use the gradient is to use the color output. I haven't used it so far because the color output has a problem in gradient as of now. This will be probably fixed in the future, but at the moment it's broken. So let me put here a gradient node with show output, and let me just put a constant color node. I'm going to put a color that is not, it's something in between. So let's see, can be this yellow, and I'm going to plug this yellow into the key color. I'm going to duplicate this gradient node, and you can see that the color propagates into the subsequent gradient nodes. Now I'm going to do the same with the mixer. And you see the color also propagates. Now, if I come here to the options in the scene, color space, and I change the picked colors to sRGB, you'll notice that the gradient colors, they get corrupted. So as I have more gradients, this color gets red and more red and more red and more red. These ones remain the same as the input they had. So there's some conversion, some color space conversion going on here when you have picked colors active. So one way to go about it is you can use one of the color space conversion nodes, either by DBNW tools or by TrueArt node library. So in here you can basically choose what's the color space conversion that you want. In this case, you want to convert from the picked colors into linear. So when I put this here, you see that linear to sRGB. Okay, so you can see that I get back my my color. Okay, so let me delete this. So this is just a heads up. There's some decay going on with the color output when you have picked colors active. So pay attention to that. But going back to our setup, here I have some morphs, and this morph looks like this, and this morph looks like this. And so in this case, I have also 3 keys set up, in which I have the one in the middle doing nothing. It's neutral. But then I have the key in the negative one and a key in the positive one that output these morphs. So now when I move my control object, what I have is a transition between one morph into neutral and from neutral into the other morph. But you can see that they actually chain nicely the motion that comes out of the transitions. So this is a way to do a setup similar to what I've mentioned in here. Another consideration about gradient is that when you have more than 2 keys, it will make it will make a soft transition. So let's just quickly look into that before ending this part. I'm going here again to instancer points on my graphing setup, and so let's see a gradient node in here. So gradient, I'm going to put this value on input. I'm going to put this in alpha. So I'm going to create a key at -1 and a key at 1. And so this one I can have, say, 0, and this other one also 0. So you'll see that it's not that linear. It actually has some easing going on. So when you have more than one key, so if I delete this key, you'll see that the transition is linear. But as I create another key, the transition becomes eased up. So if I want to keep this linearity, what I have to do is come here to each key and go into the smoothing and put linear. So this way I have an actual linear transition. So just be careful. Maybe, well, to be honest, of course, having a smooth transition is welcomed, but maybe it was something that you didn't take into account and can catch you, with your guard down. So last thing I'm going to do in this section is just show on an example of a compound that I did that basically does a more complicated rescale operation. So I praised Remap node for being simple, to the point, and very clear. So I decided to make one that it's quite complicated. So here I put the value that I want to transform. Here I define my input range. And here I define my output range. So actually here I'm putting the wrong value. So AX, BX, and AY, BY as my output range. So you'll notice here that I use, instead of just scalar values, like the remap example, I have the possibility of having a vector output range. So if I plug this in here, and as I move this object, you see that I get the same result I was having with remap. Right. Nice thing about this one is that I can, for example, clamp just one side. So call an integer constant node, and it basically works with 0 and 1. So if I put here on the clamp A, you notice that now my A side is clamped, but not my B side. And I can do the same, I can clamp B, but not A. The other thing that this compound does is that allows me to have a smooth transition, not in between the two values, but around the reference point. So for example, here, if I come here with the scalar constant, and I put 1 and I connect here on the clamped softness, you notice now that the transition, it doesn't go into B and then into A linearly. There's a slight soft transition going next to B. So this can be useful at times when sometimes we don't have issues with linear transitions. It's only the fact that it ends up abruptly that it's not so pleasant. So this is a way to cope with that. So I can increase the softness radius. I can put 2, or I can put 0.2, and it becomes really small, almost, unnoticed. And the last thing here is that I can swap the input range and I can swap the output range. So this is just, I'm not saying, to use this compound all the time. I think it's quite, it's a bit heavy compound for a simple operation, but it's one that you can open up and, understand what's going on in the example and use this as a case study, for example. But it does offer some options that the nodes or compounds that I mentioned up to now do not show. So this concludes this section about two-point linear fitting. Next, I'm going to look into easing and smoothing and having curved transitions between A and B and mapping with curves.